Welcome again. So we will solve one of the most difficult exercises of this part, the stack course. So we will implement three stack within a single array. So we have solved earlier in exercise 10, no, in exercise 9. So we kept two stacks into a single array. So now in this exercise we'll try to put three stacks into a single one array. So this is the old solution. So this is a solution for two stacks. So we have a stack that grows from the index 0 and upwards, and the stack 2 will grow from 2 till downwards, and they could meet somewhere in the middle. So we know how to implement the top and pop. However, they're asking us to use an array to implement three stacks. So they are telling us use the elements, so we should use the solution of two stacks in order to implement the three stacks. So we have one array. This is the array. So what we will do is that the first stack, it will be here, the second stack, it will be here, and obviously the third stack should be somewhere in the middle. So what we will do is that our third stack will try to grow this way. So this one will grow that way, and this way. So the top here, the top one, it points the first time to equal to -1, top 2 equal to n. We have already done that, and we have here s3, and we need to know what should we use. So here for S1, the bottom element is S0, and the top one will be used to indicate the index of the top element. However, for S2, top 2 will indicate the top the index of the top element. However, this one is always fixed. This one is always fixed. However, S3, it can move, because suppose, for example, S1 grows and reaches the bottom element of S3, and however there's some empty places here, so we need to shift S3 some elements, some cells, in order to S1 grows. So as long as we have elements, free cells in the array, and so it's not full. So this the array is not full, and we can use these elements for the stack. So for S3, we need not just one integer, we need two integers. One to indicate the top element, so top 3, and we need to use one for the bottom, for 2 points where the bottom of the third stack is. So we need to know this, where in which cell we can find the bottom element. And of course, as we have done in the first stack, so the top one should point before the first element. So top 3, when the stack is empty, when the S3 is empty, should point before bottom. So for example, if we say that bottom 3 is in n over 2, or for example n over 2 plus 1, top 3 would be in n over 2. So there should be one cell, so top 3 should be behind bottom 3. So if we want to check whether so let's begin with the easiest functions. For example, if the stack is empty, so again here, whenever we are asking the emptiness of a stack, we should specify which stack. So S1 is empty if top 1 is equal to -1, top 2 is empty if S2 equal to 2n, and S3 is empty if top 3 is less than bottom 3. So this is easy. However, for the full stack, so usually a full stack, it means that all the array is full, there is no empty cell. So what does it mean? It means that the top element is directly behind bottom 3, and that the top element 3 is directly behind top 2. So let me draw it. So if you have an array and it's full, so we have this. It means that if it's full, so here is S1, here for example S2, and here S3. So there is no empty cells. So top 1 is pointing here, bottom 3 here, top 3 here, and top 2 here. So they follow each others. So top 1, bottom 3 equal to top 1 plus 1, and top 2 equal top 3 plus 1. This is for the function for the if the stack is empty. How to check the top? So the top, so we need to check which stack. So for the first stack, the top is at position top 1. For the stack 2 is at top 2, sorry, and for S3 is at top 3. How do we pop? Let's do another draw. So S1, S3, and S2. So where's the, how do we pop? So pop, it means that we decrement top 1. In S3 we decrement top 3, and in S2 we increment top 2. So this one is easy. So the most complicated one is the push function. So because whenever we are pushing, we could have some shifting of the stack S3. So let's see. If we are pushing into S1, so if we are pushing into S1, we have to we should have the stack should not be full. So if it's full, there's no need to do all this. So this is the first rule. So if the stack is full, there is nothing to do. Suppose that we have the stack S1, which is so if the stack S1 is here, so top 1 is here and S3 is here, so I can push an element. There's a free space. Why? Because top 1 is far from bottom 3, you know. However, if this stack S1 is here, so as top 1 is followed directly by bottom 3, it means that top 1 plus 1 is equal to bottom 3. It means that they are colliding. So we need to check if there's some places, if there are some cells in between S3 and S2. So how do we check if there's the places in between? So we need to try to see the number of free cells. So the number of free cells, we can check the top element of S2 and we subtract it from top 3 minus 1 and we get the number of free cells. So here when we get the number of free cells, we can, for example, and in my solution I shifted S3 by the number of free elements over 2. So I shifted. So when I shift, for example, if I have here 4 empty cells, I'll shift the stack S3 just 2 elements. So here we will have in between S1 and S3, we will have 2 elements, and then we will add the element into S1. What we can do if I want to push in S2, so it's the same as in for the S1, however it will be in reverse direction. So if we want to push into S2 and there is no more places here, I want to check if there's place between S1 and S2, and if it's the case, I need to shift S3 backward. So again, what happens if I want to push into S3? So it will be the same operation. So this is one of the most difficult exercises, so make sure to review the question, to recheck the examples, and to try to solve it. So here, as I have said, so we will use an array. We have top 1, the index here top 1 for the stack S1 and top 2 for the stack S2. As for the stack S3, we need 2 integer top 3 and bottom 3 to indicate the index of the top element and the index of the bottom element. So in order to create a stack, we create a variable s and we put in top 1 as I have said equal -1. It's behind the first element, and in top 2 we put n, and in top 3 we put, for example, n over 2 because n is the total number of elements, and bottom 3 it should be behind. So top 3 should be behind bottom 3, so it will be equal n over 2 plus 1, and then we return s. So this is easy. In the empty, so to check whether a stack is empty, so we need to supplement it with a variable to check in order to see which stack we want to check if it's empty or not. So if n is equal to 1, it means that I want to check whether the first stack is empty or not. So I should check if top is equal to, so P here, top 1 is equal to minus 1. So if n is equal to 2, so we have a return, we don't need else. We check whether the top 2 is equal to n, and if else, so it's n equal to 3, so you can write if, you cannot, it's up to you. However, we will check if is p dot top 3 is behind p dot bottom 3. So this is for the empty stack. How to check if it's full? As we have said, there should be no empty cells in the array. It means that top 1 should be behind directly bottom 3, and top 2 should come directly after top 3. So we should return top 1 plus 1 should be equal to p dot bottom 3, right? And top 3 plus 1 should be equal to top 2. So this is the, I don't know why something is capital. Okay, so this is it. Then we move to pop. So pop, it's easy since we need to just decrement or increment the tops. So in pop, again, we need an extra integer n to check whether the stack is not empty. So we check if the stack is empty. It means that we cannot pop an element, so we return a gentle 0. Otherwise, we need to check if the stack is the stack number 1 or 2 or 3. So if it's stack number 1, it means that I need to decrement the top 1, and here we need else because we didn't use return. So if n is equal to 2, we need to increment top 2. Otherwise, it means that it's the third stack, it's like S1. It means that we need to decrement top 3, and then we return once everything is okay. For the top function, so again, if the stack is empty, the one that we want to ask, so we return 0, and we need to check. Let's copy this since we will need most of it. So if we are asking, we want to check the top element of the first stack, so we need to check the p data of p dot top 1. If n equal to 2, we need to get the top element pointed by p top 2, and for the third one we need to check the element pointed by p top 3, and this is it. The most difficult part is in the push because we need to do some shifts. So let's start. So if the stack is full, I cannot push. So if it's full, the stack is full, it means that I cannot push. If I can push, so let's see in which stack. So if n is equal to 1, I will try to push. So at the end, at somewhere in the code, I should write p arrow data. I should push pp arrow top 1 equal to e. So somewhere in the code it should be at the end. So here we'll do some conditions. If it's full, if for example top 1 is colliding with bottom 3, so it means that I should find, or I should try to shift the stack as 3. So here we will do. So what we will do first is that we check if stack 3 is collided to S1. So what we'll check is that to see whether the top 1 plus 1, if the next element, next cell after top 1 is the bottom 3. If it's equal to p arrow bottom 3, it means that I cannot push the element, that I cannot increment top 1 because there's elements related to S3. So what I should do is I'll try to shift. So here, try to shift S3. So how do we try to shift S3? Let's get the rightmost free cells, empty cells. So we'll try to check if we have cells. So let's call it empty here, the number of empty cells, and let's calculate it here. So empty would be equal to, if I'm not mistaken, is P arrow top 2 minus P arrow top 3 minus 1. So let's see an example. So if I am here, so I will not draw S1, so we have here S3, and this is top 3, sorry, this is top 2 S2, and here we have S3, this is top 3. So let's suppose that here we have 7 and here we have 10. So 7, 8, 9, 10. So how many cells do we have? We have top 2 minus top 3. 10 minus 7 equal 3, minus 1 equal 2. So right, it's top 2 minus top 3 minus 1. So here is the empty spaces. So what we will do is we try to shift S3. So we try to shift S3, those spaces over 2. So let's do a for loop. So if there's no spaces, the for loop won't work. So we need a counter. So let's also declare here an I, integer I. So let's loop I. We will loop I from P arrow top 3 till I greater than equal than P arrow bottom, so 3. So I'm looping over the elements of the third stack from the top till the bottom, and I'll try to shift it n over 2 position, or empty over 2 position. So what I would do is that I will take this element and push it here, take this element and push it here, and so on. So what we will do is that the P arrow data and equal of P arrow data of I, so the element that I would put it in I plus something. So what should we do here is that I will put it I plus and the number of empty cells over 2. I will add plus 1 just to make sure that everything is correct. So because empty over 2, it could be equal to 0 if the number of elements is odd. So here we tried to shift over n over 2 cells. So after shifting, the top index and the bottom index would be modified. So in P top 3 would be equal P top 3 plus empty over 2 plus 1. So the top element will be incremented like this, and again the bottom element will be again shifted empty over 2 spaces cells plus 1. So this is how we shift. So it's easy. So if the stack S1 is followed directly by S3, I check the empty spaces between S2 and S3, and then I will loop over the element in S3. I will shift each element which is of index I into index I plus the empty spaces n over 2 plus 1 for the odd, and then we should not forget to rectify the top and bottom element of the stack S3, and then we can increment the top element and add the element E. So this is for n equal to 1. So if we write here, so we'll try to merge the case for S2 and S3, because even if I'm pushing into S2 and I am pushing into S3, and if there is no more places here, I need to find a place here, and in both cases I need to shift backward the stack S3. So we will do the both cases at the same time because the shift is the same for both. Again, in the second part, so we need to check here the same. Try to see if if the second stack, if it collapses with the third stack. So we need to check if top 3 is followed by top 2. So if top 2, so P arrow top 2 is followed, it means that if top 2 plus 1 equal top 2 in, minus 1 is equal to P arrow top 3. So it means that we need to shift here, try to shift. So again, we need to check the number of cells on the left space. So get the leftmost empty cell. So in order to get the leftmost, we need to get the bottom 3 and the difference between the bottom 3 and top 1. So empty would be equal to, so bottom 3 is greater, so it's P arrow bottom 3 minus P arrow top 1 minus 1. So this is the number of empty cells between S3 and S1, and we'll try to shift S3 backwards. So again, 4. However, now when we are when we are moving the element backwards, so we begin by the bottom element and we get it backwards and so on. So here we will start not from like above from top, the top element, but we will start from the bottom elements. So from P arrow bottom 3 I less than or equal than P arrow top top 3 I plus plus. As you see, it's very difficult. It's a very difficult problem, and you need to be very concentrated because there's a lot of variables, there's a lot of pointers, and you should not make any mistakes. So what we do is that we need to move P arrow data of I to somewhere backwards. So it's I minus something. So it's I minus empty over 2 minus 1. So after doing the shifts, we need to rectify top 3 and bottom 3. So top 3 would be, so here 3, we have an error. So it's equal P arrow top 3 minus empty over 2 minus 1, and P bottom 3 is equal to P bottom 3 minus empty minus 1. So I hope that I didn't make any mistake in the variables. So here after shifting, so we need to check where we are pushing, if it's in the stack 2 or in the stack 3. If I'm pushing into stack 2, so I need to data. So if it's in the stack 2, it means that, and I am pushing, I need to decrement the element of the stack. So P arrow data minus P arrow top 2 equal to E, and else, so if n is equal to 3, we need to increment top 3. So P arrow data of plus P arrow top 3 equal to E. So why it's minus minus? Because and the top elements of the second stack, it grows downward, so it's decremented when I'm pushing. And at the end of everything here, if it's n1 or n2, I would return 1. So hopefully there is no error, so we'll see. If there's error, it should be some maybe a mistake in the index of the top or bottoms. So I have wrote a function for display, and the function to display all the elements in the array. So we display the stack. However, just in order to see what's the output, this one is not allowed. You are not allowed to access the element of a stack directly. This is not allowed. So I write here not allowed. I just wrote it in order to see the array. So what I will do, so I have created a stack. I have pushed variables. So I am pushing, for example, I'm starting from I equals 0 to 30. However, if we go up, the stack the stack can contain, or all the array can hold just 20 elements. So somewhere we should have, okay, we cannot push any more elements. So we start from I equal to 0 to 30. I will push the element 0 in stack 1, 2, or 3. So it's either 1, 2, or 3. I will print f. So for each push, I will try to display the content of the array. At the end, I will display the stack 1, stack 2, and I will display the data one more time. So let's run it and check what is happening. So we have here an error. So let's go to number 18. 18, we have S bottom 3. N is capital. N is capital. So let's run it again. We have more errors. So here is equal, so it's 32. It's double equal. And what we have more is empty stack, expected declaration. Where is that? In function is empty stack 159. So in function is empty stack. Let's go to is empty stack. So maybe you are using is empty stack, not like it's written here. So we should check is empty stack, is full stack, display, while top, is there's no curly braces. So run and let's see what's happening. So we have pushed, so we have I equal to 0, we have pushed 0 in 1, so we have 0 here in the stack 1. Then we have pushed 1 in 1, so we'll not spend too much time. So however, we will try to see what's happening here. So we have some errors because we have all the numbers are equal to 2. So most probably we have mistaken in some of when pushing in the S3. So there's something we should try to figure out when we are pushing into the stack S3. So pushing is here. We have if is full, and we have if n equal to 1, no, if n equal to 3, and then we will check if p top is equal to p top 3, so which is not the case. We will go to there if p arrow top minus p top 2, which is right, equal 2. Let's see here, int I, okay, empty is full if n equal to 1, if p arrow top 1. We didn't reach this case yet, so it's probably from here. Equal p top 3, we got the leftmost. Empty equal bottom 3 minus p top 1 minus 1 is correct. P, so for I equal p arrow bottom 3, I less than equal the p top 3 I plus plus. I check p arrow data, I empty over 2 minus 1 is equal to p arrow data. This is right. P top 3 equal p top 3 minus empty over 2 minus 1, and p bottom 3 is equal p bottom 3 minus empty over 2 minus 1. This is correct. And if n equal 2, we decrement n, and here we increment top 3. So what's the problem? It's equal to 2. Here's the problem, so it should be equal e. So let's rerun the example. So now it's everything, it looks like okay. So let's just make the example here and see if it's correct. So we have numbers that runs from 0 or 1, so it's from 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, and 18. We will not reach 21. So 4, 7, 10, 13, 16, and 19. And then we will have 5, 8, 11, 14, 17, and 20. So let's see if we have this in stack S1, stack S2, and stack S3. So we have 0, 3, 6, okay, and 19 until the 17. So this is how it looks at the final stack. So if you look well, we have 1, 2, 3, 4, 5, 6, 7 elements in the first stack. 1, 2, 3, 4, 5, 6, 7 elements. However, we have 6 elements in the third stack, which is equal to 20 elements. So if you can look here, you can check the shift, how it happens. And if you want to write your own test file just to know the how it works more, the shifting, you can try to put, for example, 10 elements in the first stack, and obviously the stack S3 would be shifted. So let's take this example. So I will remove this, I will keep the data. So for I equal to 0, I will push 10 elements into the first stack. So always I'm pushing into the first stack. However, the let's say not 10, 15. So I will push 15 elements just in the first stack. So let's run this. So at the end we'll have 14 elements from 0 to 14. It means 15 elements. However, the stack 3 should be pushed. So now if I will push into the stack S3, so let's see what's happening. So let's say I will push 100 into the stack S3, and let's see where it would be shifted. So S3 would contain 100. However, the element, look well, there's here a random number, and it was shifted a number of cells to the right. So if I push here now into S2, it will be on the right here. It's normal because at the end of the array. And if I'll push, for example, 3 elements, for example, I will push also the same element. So in order to have here one element for S2 and here one element, sorry, for S2 and here for S3, and then so S2 and S3 will collide. So what I'll do is that if I push an element in S2 or in S3, they should be shifted. So I'll push into S2 the element 150. So when I push 150, it should go in between it should be here. So the two elements 100 should be shifted to the left. So right, so we have 150 and it shifted to the left. So this is the code. It's a bit complicated, right? So, and you should pay attention especially for the push. So if we review the code, we have declared the stack type, which contains the array and 4 pointers, 2 for top 1 and top 2 for the stacks, which have their bottom fixed, and we have one movable stack, which is S2. We have declared all the variables. So is empty stack, full stack, and pop and top, they are easy. The push one, it's a bit complicated because we have used shifting. So this is it for this exercise. So if you have any questions, do not hesitate to send it to me, and do not forget to subscribe to my channel and to hit the bell icon to receive notifications. And thanks for watching.